Okay, as we previously focused on this particular question, we just want to do a follow-up on 9.2, the width of the box such that the cost to calculate the box to the cost to build the box is a minimum. So we just want to reduce the cost by making sure that the cost is at a minimum. Now, previously we had done a whole lot of this, trying to explain why the cost is calculated as thus because of the surface area. And in the surface area, now you have, after you calculate your surface area in terms of the width and the height, you go top and bottom. So it's 15 rand, it's 6 rand, and then gives you the cost. Now, just to go through this one, 9.2, determine the width of the box such that the cost to build the box is at a minimum. So now remember we're given the volume, and I said to you that the volume is base times height. That's the area of the base. Area of the base times the height. Just need to mention that it's the area, not base, just area of base. So it's the area of the base, and I've done the area of the base, which is L multiplied by W multiplied by the height going up, which is area of the base multiplied by the height. And we know that L is 3W, W is W, and the height is the height. Now we're going to find the height in terms of W. After finding height in terms of the W, and then now the next step is to substitute the height back into the cost. Let's put the height back into the cost and say, okay, that was our cost. I just need to substitute the height, and I've already calculated my height in terms of W. I substitute, and then here is just the mathematics, guys. It's just the mathematics that's happening there. You have 48 multiplied by 5, and then there's the W, and then you still have 3 as a denominator, W squared, 3W squared, and then the W and 1W here are going to divide out. You have a W there because there's 2 W's, there's 1, so you'll be remained with 1. And then you take it up. When you take it up, it gives you 80W to the power of 1. 80W to the power of 1. So that's what happened there. 80W to the power of 1. And the moment you differentiate now, using rules of differentiation, you get 90 multiplied by 2 is 180. Minus 1, you have W. You have now negative 1 multiplied by 80 is negative 80. Minus 1 is now negative 2 there. And then you equate to 0. The moment they speak about a minimum, the moment you hear a minimum or even maximum, the moment you hear a maximum or minimum, just equate to 0, guys. Equate to 0. Differentiate, you equate to 0. Then you solve for W. It's telling you that now our W is going to be 0.67 centimeters. 0.76 meters, sorry. 0.76 meters, almost a meter. That's 76 meters. So if you're looking at 76 meters, if I have a ruler there, the ruler is 60 centimeters. So double of that and a little bit more. So it's just double of that. If I was to put it here, say, okay, there's the ruler, and then I take it from there again. Imagine this distance all the way there. So it's quite a big box, guys. It's quite a big box because it has that width, and you know that the length is already 3 times that width, and the height we already know that it's also a portion of the width. So yeah, that's how you do that question there, guys. The width would need to be 0.76 meters, which may seem like it's little, but it's not. That's a quite sizable box because that's almost a meter. That's almost a meter. If you have a 30 centimeter ruler, Usually your 30 centimeter ruler, it's also quite long, so imagine double of that and more, and 16 and half more of that. It's quite a big box. Anyway, I don't want to explain the box. I'm just thinking about the mathematics.